Hey Mustangs, in this video we're going to be taking a look at mass extinctions. Now before we get into mass extinctions themselves, we have to take a look at regular, normal, everyday extinctions. So what we call natural extinctions or background extinctions, because there's a difference between background extinction and mass extinctions. So background extinction, these are extinctions that happen all the time, okay? A lot of people equate extinction with humans, and that humans cause extinction because we have caused a lot of animal extinction and plant extinction over the last 100 years or so. But natural extinction, background extinction, happens without humans even interfering as well. So the environment changes somehow, and some species just can't survive, so they wind up going extinct. So in background extinction, you're looking at 1 to 5 species going extinct per year. So that's normal. That's actually something that is actually expected for that many species to go extinct per year. With a mass extinction, there's a big difference. You're looking at 100 to 1,000 times faster rate of extinction. So instead of 1 to 5, you'd be looking at 100 to 500 species or 1,000 to 5,000 species going extinct per year. So that's a very, very big difference. And with mass extinctions, the cause of mass extinctions are usually some really rapid, dramatic change to the environment to where species just can't adapt. They can't change quick enough to actually survive as a species. So that's where mass extinctions and normal, natural background extinctions, that's how they differ from each other. All right, so how do we know about mass extinctions? There's actually been 5 mass extinctions that have occurred in the past, at least that we have evidence of. There may have been more, but we definitely do have evidence for 5 mass extinctions. And what we look at is stratigraphy and the fossil record. So stratigraphy, if we look here, it's the study of layers in the earth. And when we look at these layers, the older layers are towards the bottom and the newer layers of the earth are towards the top. Now, the earth keeps on building layers. That doesn't mean the crust is getting thicker and thicker, because these bottom layers are actually going back into the magma and lava down below. So it's like a conveyor belt. As this builds up down here, this gets broken apart and becomes part of the core once again there. So we don't have a buildup of the layers, but we can actually see distinct layers. And each layer is unique and distinct based on the different composition of what was in the atmosphere at the time, minerals, rocks, things being released, things being moved around. So we can actually tell a lot about each layer by studying it. Now here, when we're talking about mass extinctions, what we see is when we look at these layers, we know the oldest stuff is towards the bottom, the newer stuff is towards the top. You can follow an organism like trilobites. Trilobites were one of the most successful organisms because we find so many fossils of them. In fact, there are so many trilobite fossils that there are places you can go and dig up a trilobite fossil, and you actually get to take it home because there's so many of those fossils. So if we look at trilobites, for example, we see them in the layers, and as you go further on, you keep seeing them. So that shows that they still exist, but then all of a sudden, poof, they're all gone. Now, in a mass extinction, what we see is we find organisms in the bottom layers, and then all of a sudden, a whole bunch of them just disappear. They no longer exist anymore. So that's how we know these mass extinctions have occurred. So let's take a look at the 5 mass extinctions that have occurred in the past. So the first one was the Ordovician extinction. This was 439 million years ago. 86% of the species, based on the fossil record, what we could tell, went extinct at the time, and it was believed to be caused by a severe ice age. Now this is really cool because this connects back to what we learned about the greenhouse gas layer. So it's believed that when the Appalachian Mountains were created, when they got pushed up, they were made out of silicate rock, and silicate rock absorbs carbon dioxide. So it's believed that these Appalachian Mountains got pushed up and they started sucking a whole ton of carbon dioxide out of the atmosphere. And as a result of that, the greenhouse gas layer got thinner and the planet slipped into a rapid ice age. So organisms didn't even have a time to adjust. It just was instantly cold. So that's the Ordovician extinction. Then we go to 364 million years ago, and we're looking at the late Devonian extinction. In this one, about 75% of the species went extinct, again, based on the fossil record. Could be a little bit more, could be a little bit less. And it's believed that the evolution of land plants was the cause of this. So when plants started growing on land, they started breaking up the soil and releasing nutrients that ran off into the water. These extra nutrients going into the water caused algae blooms. Now, algae blooming, here's the problem with that. Algae blooms are a bad thing. Whether it happens in oceans, lakes, it's always bad. So the algae bloom, the algae covers the surface, blocking light to plants down below, and plants below them begin to die. Then when the algae runs out of nutrients, they begin to die, and there's plenty of food for bacteria. And when the bacteria come along, they start sucking oxygen out of the water, and that takes away oxygen from fish and other aquatic organisms, and they begin to die. So that's what is believed to have caused the late Devonian extinction. So the land plants led to algae blooms, which led to oxygen being removed from the water too quickly, and organisms died. Then we have the Permian-Triassic extinction, and this is the biggest mass extinction that we know of, that we have evidence for. This was known as the Great Dying even, 251 million years ago, and it's believed about 96% of the species went extinct at the time. So this extinction almost wiped out life on this planet, and it's believed to be contributed to volcanic eruptions in Siberia. So these volcanic eruptions released large amounts of carbon dioxide and methane. So basically, it's the opposite of what we saw before with the silicate rocks sucking carbon dioxide out of the atmosphere. Here, so much methane and carbon dioxide got put into the atmosphere so rapidly, made the greenhouse gas layer thick extremely quickly, and the planet heated up like that. So that's what's believed to have caused the Permian-Triassic extinction. Then you have the End-Triassic extinction, 199 million years ago. 80% of the species went extinct, and we don't exactly know what caused this one. And then finally, the one that you're probably most familiar with, so the Cretaceous extinction. So in this extinction, 65 million years ago, the reason why you know so much about this is because this is the one that wiped out the dinosaurs. So here, it's believed an asteroid hit the planet. We believe we know the location because we actually find a crater down here by the Yucatan Peninsula. And when that asteroid hit, it shot so much dust and debris up into the atmosphere, and it spread around the planet, and it blocked out the sun. Well, if you block out the sun, that means you're stopping plants from doing photosynthesis. Plants are the base of the food chain, so if plants die, everything else in the food chain begins to die. So that's what's believed to have caused this one. How do we know that it was here in the Gulf of Mexico that the asteroid hit? Well, not only have we actually found a crater, we actually find, when you go and look all around the planet, the minerals, the composition of minerals, the percents and stuff that you actually find in this area, we find a thin layer of that all over the entire world. So that would indicate that the asteroid hit, shot up all that dust and debris from that area, from that region, and then as it went around the planet, it slowly started to settle, and it formed a thin layer all around the entire planet. So it's pretty cool that we could actually find that. Now, that's the 5 mass extinctions that we have evidence for. Now scientists are saying that we're in the 6th mass extinction. So the 6th mass extinction is believed to be happening right now, as we're sitting here, as I'm talking to you. At this point, about 784 species have gone extinct, and the cause is believed to be humans. Now, you're going to be watching a video called Race and Extinction, a movie called Race and Extinction, and it's really, really good. Every year when I show this, I have students be very motivated to want to do something, and I even have some students cry at the end. Guys and girls I've actually seen cry, or even have like watery eyes at the end of that documentary. And it's looking at the fact that humans are the cause of this 6th mass extinction. All the things that we're doing, all those 4 human threats that we talked about before. And there's a great line in it that one of the people in the documentary actually say, and they say, humans are now the asteroid. Because we could connect to that. We know that an asteroid wiped out the dinosaurs and how devastating it was, how it killed off all the dinosaurs, plus all the other species that exist, many other species that exist at the time. Here, humans are like the asteroid. We are the destructive force that's causing change so rapidly that species can't keep up. So we've seen many extinctions, including several of these organisms that you see right here. And we've also seen coral bleaching. So not just the big organisms are going extinct. Plants, animals, the ocean is having a problem. As the water temperature heats up, the coral begins to die. And if the coral dies, there goes whole aquatic ecosystems right there. So it's definitely having a big, big effect. And it's something that we should definitely be taking a look at. So here it's believed that we're in the 6th mass extinction.